Okay.
Professor,
Help. Yes.
you didn't send the previous recording of the lecture.
Okay. Okay. Thank
I
you.
asked
Just
to
1
send.
second. I will do it just right now. Just 1 minute.
Okay, thank you.
Yeah. Okay. Thank you. That repeat it once more. That remember me. Okay, just 1 minute. I download our videos on YouTube account and will send a playlist with both of previous videos about repeating, and also will add today's video to just the internet little bit slowly and
Okay.
YouTube downloads slowly. Yeah, here they are. Send link in our Telegram group. Okay, maybe any other questions before we start? Okay. Okay, then let's continue our material repeating about direct current that you had all videos, that you will have all videos about our material. Last time we, yeah, okay. Last time we finished on the element transformation, how we could simplify our electrical circle, how we could substitute some part of system or some part of mathematical model for the other part, how we could do such called star delta transformation of resistors or other type of transformation as serial or parallel connection of resistors or of sources of energy. And after that, to apply Ohm law for simple circle. It was our previous point that we finished. Today, let's continue for a superposition method and Thevenin's theorem, the last parts of repeating direct current material. What these 2 points is about. The superposition theorem has just nice idea. One moment. Here it is. The superposition theorem. It tells us about that if our electrical circle is linear, then our sources of energy works independently. That is mean that each action of each source could be described or could be mathematically calculated separately, independently on all others. And then we could divide a circle with couple of sources on couple of simple circles in which only one source is present. Just step by step. What does it mean linear? Because it is the main restriction on our method application. The linear is mean that all our resistors are constants, just like numbers. For example, if we know that resistivity 100 ohm, then it should be 100 ohm independently on any other functions, independently on temperature, independently on current rate, independently on electromotive force or any other situation. Just if resistor is a number, it is a number for any working mode of our system. It is mean that volt-ampere characteristic of that element, the dependence between applied voltage and applied current that arise from the Ohm law, it should be a linear function, just a straight line. Because if resistivity is constant, then as much you increase voltage, the same rate you increase current. That is why this situation is called linear element. And then if all elements are linear, you obtain linear circle. The other case, if your resistivity is a function, could be a variable, some function from or temperature or current rate or any other argument could vary. That is mean that if you will substitute different values instead of your resistivity, for example, a resistivity could be some function of current rate, some constant alpha, and for example, multiply on current. As much you increase current, as higher resistivity you will get. Or some function of temperature. Some constant multiply on temperature. As higher temperature you have, as higher resistivity you get. In this situation, the voltage current dependence could be some curve, not a straight line. And this situation is called non-linear element. And if one or more elements are present in our circle non-linear, then whole our circle became non-linear. And why is this problem? For example, if your resistivity depends from current, okay, about the idea of method, and then why it isn't work on non-linear case. What is idea of this method? The idea of superposition methods, just a moment. The idea is just like that. If you have circle with couple of sources, then your sources work independently. And instead of complex circle with lots of sources, you could calculate couple of simple circles in which only one source is present. For example, you have some system with two electromotive forces and one current source. For example, you have two electromotive forces, E1 and E2. You have current source J. You have couple of resistors, R1, R2, R3, R4, and R5. Our system. And for example, the last resistor, R6. Then, instead of this circle, you could calculate three independent circles in which only one source is present, because we assume that they are working independently. First, you are taking the source number one, drawing the circle with only one source, and other sources you substitute by the internal resistance. The internal resistance of that is mean that you just disconnect them, just turning them off. The internal resistor resistivity of electromotive force, and the source of voltage. It 0, then you substitute by a straight connection, and the internal resistance of source of current is infinity. Then instead of this source, you are substituting the open circle. Then you are doing the same for the second part. You are calculating circle only with second source. Substituting the first source as a single wire and the current source as an open circle. And the last one, calculating the current source only current source that is working in our circle. Here it is. Here what you get. That is mean, if you want to find some current, for example, you want to find some current I6 in the resistor number 6. Instead of calculating it in this circle, because this circle has 3 sources, it is quite nice if the sources are the same value. For example, direct current or sinusoidal current. But in some situation, they even could be the different type of supply. And they could, some of them could be direct current, some of them could be alternating current. And in this case, you cannot calculate them simultaneously because you cannot use mathematics in such type. Because in sinusoidal current, you should use complex number. In direct current, you should use constants, just general numbers. And if you have this, both of these cases, you cannot use both of these mathematics. And for example, one of sources could be some pulse source or with some exponent function. And the main question, if you have different type of sources, which mathematic you should use in this mathematical model. That is why quite useful for linear circle to use superposition method to divide complex situation on the simple situations with only one source. And if you want to find, for example, current I6, then you have to find this current in each case, the smaller current rate only from one source. And then in each circle, add these three values. Add these three values and obtain the superposition of these three currents. That is why it's called superposition theorem. You are adding partial cases to obtain the whole one. Okay. And then returning why to the question why the superposition theorem doesn't work if you have nonlinear circle, because of functional dependence. If you have linear case, you are substituting the same resistor in each partial circle. But if your resistivity could change, if you have different values for resistivity, you don't know which R you should substitute in nonlinear case. That is why generally superposition theorem isn't used in nonlinear case. Only in linear one when you have constants. And in our course, we also will use this situation only in linear case, and we will try this superposition theorem. Is the general idea how to use this theorem? Is it okay? Is it clear? The general idea of method.
Yes.
Okay, perfect. Then let's see how it could be applied on the practical cases. The general background, the general idea. We are using the superposition principle, just adding a partial actions of our sources. When we disconnect in some source, the ideal voltage source could be substituted as short circle, just a single wire with zero resistance. And if we are substituting the current source, we are substituting as open circle the infinity high value of resistivity. Then just adding all currents and all voltages in partial cases in partial circles. Let's see how it works. More simple case, just for quicker mathematics. Two sources, voltage source 10 volts, a current source 1 amperes, two resistivity 10 ohm and 5 ohm, and we are divide in on partial cases. In first case, only voltage source works, and current source we substitute on infinity high resistivity. And second case, current source and the voltage source we substitute on zero resistivity. And calculating each partial case. For example, if we want to find current I1, we have to find current I1 with index 1 and current I1 with index 3. And then add them all together, and it will be the primary current I1 in this situation. Just one notification that we have to look on the direction and add taking the direction into account. Let's move one step earlier. We are looking for current I1, I2, and I3. But in first partial circle, we have electromotive force. It gives us the direction of current like here, and zero current in the right branch. And our current source gives us current directions like this. And we are comparing. In first situation, current I1. Sorry, just one moment. Sorry, just one moment.